And with that, it's a pleasure to introduce my new speaker. If he is already here, I'm just looking at the door. If not, we'll give him a couple of minutes. It should be Jochen Papenbrock, so if this is you, feel free to come up on stage. This is you, you're already here, great. So I can start with my quick introduction. So you'll be talking for the next around 15 to 20 minutes about Gaia-x, FAIC, Democratizing AI and Technology for Sustainable Finance and ESG. You spent the last 15 years in various roles working on AI and financial services. You're a financial data scientist by training, trained at the KIT, and it's a pleasure to have you here. Welcome at Big Data AI Summit.
Thank you. So let me test technology works. Yeah, thanks a lot also to Bitkom for this interesting, great conference, and thanks for having us here. So today I will talk about a topic that is focused on financial services, but it can be extended to many other industries. I guess sustainability and climate risk mitigation is a topic that affects a lot of industries. So before I start, I will briefly introduce NVIDIA. For those of you who don't know NVIDIA, it's currently the leading AI computing platform. Many people know that we are in gaming. That's right. And gaming actually is a very complicated real-life simulation. And there you need special chips called graphics processing units that can process data in parallel. And this principle was used very effectively and very systematically in NVIDIA to also explore other areas of activity, namely supercomputing, high-performance computing, and also AI model building and inferencing. So NVIDIA today is not only a chip designer, but also it is a software company, because more than 70% of our colleagues are software engineers. Just producing super fast parallel chips is not enough. You need a good software to operate. And we are also embracing the open source ecosystem. So a lot of the codes and software development kits that we develop are linked to Python ecosystem and to other open source Apache projects, for example. So basically, an accelerated computing platform has this bottom hardware layer that you see. So it's not just the GPU, it's also the CPU that everyone has in their PCs. And also the data processing units, you need also to network and to connect all these components. So to really build an accelerated supercomputing machine or an AI simulation and simulation factory, you need all these components that you see below there. Then we have the software system layer. And in the end, we have created those three platforms. So one of them is for high-performance computing, the other one for AI. The third one is Omniverse, which is basically a industrial metaverse technology. And last but not least, this is what our software guys are mainly producing, is the application frameworks. So it's much easier these days to use these superpowers of accelerated computing. For example, if you want to build a recommendation engine, you can use Modulus. If you want to work in healthcare, and there's Clara. Riva is our speech AI, and so forth, right? So it can be used in robotics. It can be used to build AI avatars, which is nothing else than a digital robot. And also in Drive, of course, for autonomous driving. In Germany, we work with a lot of companies, including DAX companies like Mercedes, BMW, Bosch, and so forth. With Siemens, we recently announced a collaboration on the industrial metaverse, actually. So later on, I will explain a little bit what that is and how we can use it for sustainable finance and in climate intelligence. So to focus more now on the financial topic or financial services topic that I prepared, most of you might know what ESG is. So ESG is sort of a scoring rating of companies, how well they are doing in terms of environmental, social, and governance. And the standards and the regulation and disclosure requirements are getting stricter these days. So maybe in the future, companies not only have to publish their balance sheet and P&L, but also how well they are doing in terms of E and S and G. So it's now also becoming part of regulation. However, those taxonomies that we have and the frameworks and also the standards are not quite fully developed. So currently, companies can more or less disclose what they want in the format they want and so forth. There are many standardization efforts. One of them, maybe the most important one, is the ISSB in Frankfurt. So that's like a reporting standards for sustainability. And the way this ESG framework is currently organized, it could be improved. So we currently see an emergence of data utilization and assistive technologies to improve these ESG scorings. So an evidence-based and data-driven approach would lead to a more neutral, unbiased, and more consistent scoring approach, and enables also a better coverage of undisclosed information. So financial institutions like investment companies and banks are very interested in these ESG scorings, in the improvement of them. And I think the general public should also be interested in that, because only if the ESG rating really reflects more or less reality of a company, how well it is doing in terms of E and S and G, it will have the consequence that those companies that do better get better credits or get better access to capital in the capital markets. So we really need to work on a more efficient ESG approach, and that's why we are currently seeing an ESG modernization, more or less. And technologies for data-driven AI-powered ESG, for example, are natural language processing to identify greenwashing, also geospatial AI, and also simulation. And for example, for the processing of geospatial data, it's very clear that you need an accelerated computing platform, because satellite imagery is so hard to read, and it takes hours. Here on the top you see the usual process that many take. It's the geospatial processing today, and it takes hours. And you can accelerate all this, bringing it to almost real time or sub-minute. And then you can imagine that it's also much cheaper if you are so fast, because you need less resources to produce the same insight. Geospatial data, geospatial ESG is on the rise. So looking at companies, at production lines, at supply chains from the sky, basically, using also remote sensing, drone data, all these data can be used for the ESG analysis. And this is a holistic overview, basically, what other technologies and data sources can be used in ESG. So, for example, natural language processing is able to read all these disclosure reports by companies. Some companies disclose their information in terms of tables or pictures. So you need to extract that information. And then you are able, after this digitization of ESG reports, to compare all the companies to each other and identify greenwashing potentially. The next column here, Earth observation and geospatial AI, that's what I already mentioned. So combining satellite data with other models would identify how companies are, how good they are in terms of deforestation, how much water they use, if they destroy biodiversity, and all these very important issues. So it's like a policing from sky sort of, or let's say an auditing process that can be established by using this data. If you don't have data like geospatial or natural language, text or text-based data for NLP, you can start to simulate things. For example, using SDKs for Monte Carlo simulation or other simulation engines to sort of predict climate change, for example, and see what is the impact on certain companies. Another important tool that I would like to mention here is Modulus. Modulus is an SDK that allows to build high-fidelity surrogate models, so you can simulate, or you can have physics-informed simulation. That means you can simulate wind, fire, moisture, sunbeams, and all these things to see what is the impact of this on companies, on supply chains. And last but not least, we have Omniverse, which is a real-time virtual world simulation and 3D collaboration engine. So there you can visualize things and With the modulus, you can simulate things, so you can bring these technologies together. Last but not least, we also see, of course, application area for quantum computing. NVIDIA is also active here to simulate quantum computing, which can be much faster and reliable and cheaper. So using a traditional computer to simulate quantum computing circuits is the idea here. So this is in the end how such a stack looks like, a sustainable finance AI platform. So the bottom layer you have sort of hardware. Then you have the availability of these systems in OEM partners, for example, Dell or HPE, so people can build on-premise enterprise AI systems. Otherwise, the other opportunity is to build these systems in the cloud, because NVIDIA Accelerated Computing Platform is available in all these clouds. We also work a lot with ISVs, independent software vendors and startups. We have 10,000 startups in our program globally. So many of them leverage this accelerated computing, and we mention here some of them that are active in the geospatial AI and climate intelligence area. Also, we work a lot with global solution integrators like Deloitte. So in the end, this entire ecosystem and software stack helps to build sustainable finance solutions and to develop structures and strategies to mitigate climate change in finance. So that makes the financial system a bit more stable. The biggest project that's currently under, it's still in progress, let's say, it's this Earth 2 project. So that's basically a digital twin of the Earth. And it's about to simulate on a very fine granular level physical phenomena like sunbeams, moisture, water, and all these things. So in the end, we are able to use supercomputing powers to predict climate change. And that's, of course, a very powerful instrument to develop risk mitigation strategies, maybe even improvement strategies. So Earth 2 is basically the combination of all the tools that we have. It's AI frameworks, it's simulation, it's also this physics-informed, physics-accurate machine learning that I mentioned, Modulus. And it's Omniverse, our digital twin platform. It's basically a 3D collaboration and visualization engine, because that will be like the future of the future GUI that we will see after internet. It's going to be more or less the metaverse, the industrial metaverse, the omniverse, the digital twin world, basically. So that's Digital Earth Twin. The central banks are also very engaged in this greening the financial system story. So, for example, here we contributed also to a conference by the central bank community on statistics for sustainable finance. I would call it maybe more big data and AI these days. What the purpose is here to collect data, to use intelligent systems basically to green the financial system. And here we suggest, of course, an accelerated computing component already at the beginning when data is collected, namely to identify outliers, gaps in the data, maybe fill data gaps with synthetic data, and then coming quickly to insights with this data once we have collected it. So this is a big process, a big project, of course, and it has only just begun. In the last few minutes, I would like to highlight what we are doing in the Gaia-x project Financial AI Cluster. It has been established 2 years ago. It's a small group of consortium companies that work in this specific project. It's not so much focused on data, because we have already many Gaia-x projects focused on financial data spaces or also space data space. Rather, we want to develop methodologies here and a marketplace for models, for application frameworks that use this data. So one of the purposes here is actually to build a marketplace for tools and instruments to implement trustworthy AI, explainable AI, but also to help validate models. So how to improve AI quality using technologies like accelerated computing, MLOps, and so forth. So that's one of the purposes. And the second purpose is actually what I just introduced today here, working on use cases in financial services using geospatial data, using climate intelligence simulation tools, metaverse, and all these other technologies that I mentioned. And there are many use cases there, and we're getting more and more of these every week, basically. One of the key use cases, of course, is to help the financial service industry to build ESG investment indices that are more realistic in that sense, with the next generation of sustainability metrics and ratings. Also, we support advanced risk modeling and, as I mentioned, climate mitigation or climate risk strategies with the technologies that were mentioned. For example, with Hewlett-Packard Enterprise, we have built in Stuttgart a demonstrator where it's like an explainable AI as a service, the world's first, I believe. So it's about, let's say like a technical inspection company that helps to validate models. They can use this service, or also a bank internally could use such a service to explain models. And of course, explaining a model takes a lot of time. It's very compute intense, so that's the reason why we are engaging here. Yeah, that's basically my presentation. In the last 15 seconds, maybe give you some insight where are next steps, where you find more material about what I just discussed. So we are having our GTC conference September 19 to 22. So that's currently the largest AI conference globally, and the registration is free. And all the presentations there can also be watched on demand. And there are many also contributions on climate intelligence, as I mentioned in the beginning, can be used for many other industries besides financial services. Myself, I will also host a watch party where we have a session by Bernd Leukert from Deutsche Bank, and he will talk about his journey to banking with technology. And yeah, you are invited to watch that. And again, registration is free. Thanks a lot for the attention.
Thank you very much, Jochen, for your presentation. We, again, have a couple of minutes left, so if there are any questions about your presentation, just looking at you. They're all too shy to ask questions, but I have one, because I was really curious learning more about your Earth 2 project. You said it's kind of work in progress, so can you give us kind of a timeline of when we can expect to see results, or what are the next steps within the project?
I think it takes a couple of months, maybe even years to finish. The technology stack is clear. I just presented what we need as components: Omniverse, Modulus, supercomputing. So it will be the largest supercomputer just dedicated to forecasting climate change. And one of the outcomes that we already see is a project called ForecastNet, like number 4, CastNet. And that's basically a project that demonstrates how this will potentially work in the future. And it's about climate and weather forecast with more accuracy beyond days and weeks, and so including a very granular approach. That means you can look at regions, at areas, maybe even some maybe manufactory or some house buildings, cities or something like that. So that's really something that is needed also by industry, financial industry, to have a very granular and local view on things, what's really happening, because climate changes from region to region. For example, if there's increase in moisture in some regions, this will have dramatic impact on the building and how long they last. And this is interesting for insurance companies, just to give an example.
Thank you very much. So I guess we're all really excited to see the first results and how this is going forward. So again, thank you very much for joining us today. And I'm sure you'll also stick around if there are any follow-up questions from the audience. Thank you very much.
Thank you.